So problem 6 is a couple of mechanisms. The first one I think looks complicated, but the chemistry I think is, at least in my opinion, is relatively straightforward. So the way that I want to illustrate this question is, imagine that you just had this molecule reacting, so this is a dialdehyde right here. So this particular, so imagine that you just have this reacting with formaldehyde. So if you were to see a molecule like this should look extraordinarily similar, or should look extraordinarily familiar. And so what you should compare this to is the diethyl malonate chemistry that we've talked so much about. So diethyl malonate looks like this. And you have a position that's very acidic. And so it's the exact same thing here. This is very acidic. And then this, hopefully you can recognize as a very good electrophile. So the initial step is addition there. Right. And that is the exact step which I'm trying to illustrate here. So you can think about this as a formal negative charge just drawn in the enolate form. This will undergo nucleophilic addition to this aldehyde. Right. And so just look at this reaction in that form. So if you look at this reaction just without the rest of the molecule, hopefully you can look at it and say, you know what, I understand this. This is relatively straightforward. And then the exact same reaction happens a second time. And then the idea here is that you go from aldol addition to aldol condensation. What condensation means is you just lose water. So a combination of this hydrogen and this hydrogen, I'm not going to go through the step-by-step mechanism, but you can see that going from here, that this gets lost as water through a very traditional condensation mechanism. And if you're not familiar with the aldol condensation mechanism, you can look at it in the book. It's relatively straightforward. Okay, so now we have this molecule. Right? Or you could go ahead and draw it in such a mechanism where you had this molecule. It's just a double condensation. And so a second molecule of this will react. So probably, in the original question, there probably should have been a 2 up here. But so here, now again, this should look very familiar to you. This looks very similar to the malonate chemistry. And here, instead of having aldol addition, you have conjugate addition, right? So here it's just conjugate addition. And that we covered conjugate addition last semester to give you that product. So then, as the mechanism is drawn here, you undergo one more condensation step, and then generate one more enolate here, which undergoes conjugate addition again. Okay. So this molecule looks complicated, but this problem is actually not as complicated as it seems. So the first step that we want to think about here is, so how do you go from this molecule to this molecule? So the first step here is acid catalyst. And so the important step here to realize is that what this is doing is taking this ketal and if you're not familiar with this, I'm looking it up right now, you want to look at chapter 14 that'll talk about ketal formation. So the acid catalyst is converting these two ketals to this corresponding ketones. Okay. Once those ketones are formed, hopefully you can realize that you have this amine, that amine is going to very rapidly form the imine. So right here is your imine. Sorry. And then at that point, you have a very interesting situation. So your imine, in this case, is actually a very good electrophile. This becomes a very good electrophile. And so the point that the important part of understanding this reaction is to realize that this methyl ketone, so we draw it like this, but it's actually better to draw it like this if you want to get to this product, can potentially undergo, it's not a formal aldol addition, but if you form an enol at this position, so ignore that, this portion of the molecule then becomes a good nucleophile, and then this portion of the molecule becomes a good electrophile. So the important part here is that this is completely analogous to an aldol addition. The only difference is that number one, the molecule is complicated, but number two, that instead of adding to either a ketone or aldehyde, you're adding to an imine. Right? Mechanistically, this is very similar to a type of reaction that I showed earlier in the problem set of reductive amination. Right?